Okay, this is going to be a quick video showing my students who've just started GCSE Electronics how to get started using Circuit Wizard, and as well as that, what we're going to do, because we're not using Control Studio, which the notes are suggesting that we use, we're going to do a similar sort of thing but using Circuit Wizard instead. So if you have a quick look at the notes from WJEC, they're suggesting that we could make a system, electronic system that uses these subsystems. So the input subsystems, read switch and push switch, so they're going to give us digital input. Then there's going to be an AND gate, so that's going to logically AND those two inputs. So if they are both true, then the output of the AND gate will be true. And then the AND gate itself can't provide much current, so then the output of the AND gate is going to go as an input to the transducer driver. Transducer driver is going to amplify the current, which is then able to drive the output component, which in this case is a solenoid. So I'm going to give a demonstration of that circuit working, and then we'll work back. I'll show you how to make it. So I'm in Circuit Wizard now. I've clicked the run button. These are the two inputs. So that one now means that is logic high. If you hover over it, you'll see that's 5 volts, whereas before it was 0 volts. So logic high there, and you'll see that when both the inputs into the AND gate are true or high, then the output of the AND gate is also high, and that's then the necessary signal for the N-channel MOSFET, which is acting as a switch in this case, which then allows current to flow through the coil of the solenoid. Don't worry about the purpose of the diode. We're going to learn a lot more about MOSFETs, solenoids, diodes. Don't worry about the detail in this. Let's just get started with making this. So if you want to make the circuit, you just click the new button, and we want to make an electronic circuit. Choose this one. It doesn't actually make a difference whether you choose flowchart or basic, but don't choose one of the others. I suggest going for flowchart because at some later date we will be in flowcharts. So click on OK. We've got a new blank document. Let's go for power supply. So we need a power supply now. You may be tempted to use a battery. I'm going to suggest that you use a voltage rail instead. You just click it and drag it. I can zoom in with the wheel on the mouse, and I'm going to double click that voltage rail. It's currently 5 volts. I'm just going to type 12, click on OK, so that's now a 12 volt supply. Next thing that I want to have is I want to have the output component, the solenoid, so I'm going to go on down. So output components, electromagnetic, electromechanical, find the solenoid like that. I'm going to click and just drag and then just release there, so that's now joined up. Then I want a MOSFET. A MOSFET is what we call a discrete semiconductor, and we can find an N-channel MOSFET. That's the one you want. Don't get confused with P-channel. N-channel. Drag it there. Join that wire up like so, and then the current's going to flow conventionally. We say conventional current flows from positive down to 0. So we haven't got anywhere for the current flow at the moment, so we need a ground. You could, if you wanted, have 0 volts, but it's conventional to put ground in. So let's have ground. Ground is at 0 potential. And if you were to run this, we can just click run there and actually find the solenoid doesn't do anything, because remember, the MOSFET needs a signal in to actually operate as the switch. So next thing then, we need the AND gate. So we look for logic gates. AND gate, drag that there, pull that across like that, and then we need a couple of inputs. We need the read switch and the push switch. Well, we're not going to use switches, we just simulate them using inputs like that. And I'm going to go click, and then I'll click, click, and then click like that. I want to duplicate this. I could just drag another one in, but what I'm going to do, I'm going to press and hold the control key and then drag like that. It's a really quick way of copying, and go across like that. Okay, now it sort of will work at the moment, but there is a problem, and let's just try running it. And sure enough, yeah, the solenoid works. And if you've only got one of the inputs high, then the solenoid is not activated. You can actually click logic levels if you want. You'll see 1 and 0, the output is 0. 1 and 1, the output's 1. 0 and 1, the output's 0. 0 and 0, the output's 0. Let's just go back to normal view. Now, if we go Project Simulation Explosions, let's try this again. All seems to be working well. Whoops! Our in-channel MOSFET's blown up. Now, there's two issues here. First one is the solenoid is of the wrong voltage, so we've got 12 volt supply, solenoid 6 volts, so let's change that to 12 so they match. But I'm still not going to fix the problem. Still blows up. What you need here is a diode, we say, in reverse bias. Now, we're going to learn more about this in another lesson, so don't get hung up on this for the moment, just drag it in. So, once again, it's not once again, it's in discrete semiconductors diodes. If you want, you can click discrete semiconductors, but then it gives you all the things there. If you want, you can hone down, you can click diodes, and then you only get diodes. So we need a diode, but we need the diode the other way around. We need it pointing upwards. Now to do that, you can click on the component, you can click these buttons, but frankly I rarely do that. I normally click it, select it, and then press Ctrl R rotates it clockwise, or Ctrl L rotates it anti-clockwise. So it's up to you. If you want to use the buttons, it's fine. So I'm going to drag that there, join that there. In this configuration, this diode is what we call a freewheeling diode or a flyback diode. As I said, we're going to learn more about this, so don't worry about it for the moment. But it provides a protection that we need, protection to the MOSFET. So now we've activated, or we've energized that coil, we've got current going through. In fact, let's just hover for a moment. Yep, you'll see that you've got 258 milliamps, or approximately a quarter of an amp of current flowing through that coil. And then when the output of the AND gate is logic low, let's just go to logic levels. When the output is logic low, then the MOSFET switch turns off. And you'll have next to no current going through, in fact, no current, it says. Alright, so that's the working circuit. That is complete, and it's more or less equivalent to this circuit here. We got the read switch, push switch. We got the two digital inputs, because remember, read switch and push switch, the switches, they have two states, so digital. AND gate, got the AND gate there, transducer driver, MOSFET, and then the solenoid there. So that's the input. That's a process. That's another process, but this specific process is called a transducer driver. And then we've got the output. That's not in itself really the output. Okay, I hope that is useful.